All right, so the purpose of this is to get you a little more used to looking at breadboards and also introduce a little bit about circuit diagrams, how those relate to the physical connections on breadboards, and also to start to introduce the idea of connecting things in series. So this is the very first activity, the first actually building activity. The first one is just a paper one in the circuit kit booklet. And we can see there's a couple of diagrams in here. There's this one, which is a circuit schematic. And then there is this one, which is an actual picture of how things are supposed to be connected on a breadboard. And I have actually connected up these components on a breadboard exactly like this. So let's take a look. We have the battery. The positive terminal of the battery is connected to the blue wire of the lamp. And then current's going to flow through the lamp, through the yellow wire. And then that yellow wire is connected to this resistor. And then once I connect this resistor back up to the other side of the battery, the lamp will turn on. There we go. So right now, current is flowing from the battery through both the lamp and the resistor, and then back to the battery using the breadboard connections. The resistor does actually slow down the current through the lamp, even though it comes sort of after it in the circuit. And that's because if you think about plugging up the end of the straw in the air demo, that's going to slow down the air through the entire straw. So it doesn't really matter where the current's being slowed down. We could switch the order of these two and we would still get basically the same result. Okay. Now let's compare this to the more abstract circuit diagram that the book starts off with. This diagram is a more useful representation of what this circuit is doing because it kind of gets rid of a lot of the extra details about physically exactly where the wires are positioned and is just about what is connected to what. So this pattern of long and short lines represents a battery. Anything that's connected by just a straight line represents a connection through the circuit. It could be through just a single wire, it could be through multiple wires, multiple steps in a breadboard, but if two things are connected, they have a straight line between them. This curly thing represents the lamp, and the zigzag represents the resistor. So this diagram is telling the same sort of story as the breadboard, but without the specific information of exactly which hole everything is plugged into, because that doesn't really matter for the circuit. The positive side of a battery usually will be labeled with a plus, but also is always the longer line. I'm actually going to take the circuit apart and use this diagram instead to make the circuit. And we should get the same result, everything working the same way as it did before. But it doesn't need to be in this exact arrangement that we saw on the other page. It could be arranged lots of different ways and still have the same outcome as long as we have the same connections. So maybe I'll try to orient it more like the diagram has. If I take my components out, what I usually like to do is put the two ends of my battery from left to right and then make the connections from there so that I can see how current is getting from this wire to this wire. And the steps that we can see on the diagram is from the positive terminal, tracing through the circuit, it goes through the lamp, and then through the resistor. So from the positive terminal of the battery, that's connected directly to the lamp. So I will plug the lamp into the same row. And then the other side of the lamp is connected to the resistor. So I will take the resistor and plug it in the same row as the lamp. And then the other side of the resistor is connected to the negative side of the battery. So I'll take this other end of the resistor wire and connect that to the battery. So this is a different implementation of this diagram. Everything is still connected the same way. I still have the lamp lit up. It's the same amount of brightness that it was before. Same results, even though this looks pretty much completely different from the way that I had it hooked up before. Okay. Let's talk about, so I'm going to unplug this for now. It's not good to leave lamp on for too long. Let's talk about things connected in series. So what that means is that the current has no choice if it wants to get from the positive to the negative, which remember, conventional current, we think about positive charges moving. They want to get away from these positive charges and they want to get towards these negative charges. That current has no choice. It needs to go through both of these components in order to get back here. So you have one steady stream of current that's going to flow through this entire circuit, and it's going to go first through the lamp, then through the resistor. The lamp and the resistor both have the ability to slow down the current, and when they do that, they actually can sort of extract energy from it. So when we see the lamp lighting up, that's a result of the lamp sort of slowing down the current and taking some energy from it. When we have components connected like this, where the current is going to flow first through one and then through the next one, we call this connected in series. Just like reading a series of books, you have to read each one in order. You're not just like skipping around or only reading some of them. If you read the entire series, you're starting at the beginning and going through to the end. And because they both have the ability to slow down the current, what ends up happening is that the total amount of resistance that the current sees is going to be more than just dealing with one or the other. In fact, the resistance of these two things together in series is going to be added together, and we'll talk about that more next. But because it has both of these sort of obstacles to get through, the lamp and the resistor, to get back to the negative side of the battery, the current has more resistance than it would have just through this resistor or just through this lamp. In fact, it would be a bad idea to hook either one of these up to the battery independently. We would get more current than we really would want to get at once, and it could either burn out the lamp or heat up this resistor pretty hot.